Hey everyone, welcome. Today, we're going to put on our architect hats and really dig into designing a public-facing API on AWS. One that's not just functional, but robust, secure, and ready to scale. So if you've ever had to build that digital front door for your application, you are in the right place. So this is the big question, right? It's the core challenge. Every app that needs to talk to the outside world, whether it's a mobile app, a partner integration, you name it, it needs a reliable entry point. And that front door, well, it can't just be wide open. It has to be smart, it has to be secure, and it has to be resilient. Okay, so to make this all feel real, we're going to follow the life of a single API request from start to finish. Let's imagine we're building a simple e-commerce API that lets a customer look up product details. We're going to build it piece by piece, and we'll make all the key architectural decisions as we go. Our journey starts right at the very beginning, at the first point of contact, the front door. Every single API request has to show up somewhere. And in the AWS world, that front door is almost always going to be API Gateway. So let's dig into why this is our foundational building block. I love this analogy. Think of API Gateway as the super skilled receptionist for your entire application. It greets every visitor, it checks their credentials, it knows exactly where to send their request, and it keeps a log of who's coming and going. And you know the best part? It's a fully managed service. That means AWS handles all the heavy lifting of keeping it running 24/7, so you don't have to. And boom, right away we hit our first big decision. You've got two main flavors here. Do we go with the feature-packed REST API? This gives us all sorts of granular controls, like unique API keys for different partners or complex throttling rules. Or is our goal just pure speed and efficiency? In that case, the lighter, more cost-effective HTTP API might be the perfect fit. So for our e-commerce example, if we're building an API for external vendors, we probably want the control of the REST API. But if it's just for our own mobile app, the speed of the HTTP API is likely the winner. Okay, so our API gateway, our receptionist, has accepted the request. The next logical question is, where does it send that request to actually get the work done? And that brings us to the compute layer, the real brains behind the whole operation. This four-step journey you're seeing here, it's a classic, and it's a really powerful pattern. The client calls the gateway routes it to compute queries the data store. Then the response just flows cleanly all the way back. The beauty of this is its simplicity, right? Each piece is decoupled, which makes the whole thing so much easier to manage and to scale. And when we say compute on AWS, you've got some amazing choices. We could use AWS Lambda. It's a serverless function that spins up instantly, does its job, and vanishes. It's perfect for simple lookups. Or maybe our logic is already packed up in Docker containers. In that case, we'd use Amazon ECS. And for really complex microservice-based apps, Amazon EKS gives you the full power of Kubernetes, just managed by AWS. So at this point, we've got a functional API. A request comes in, it gets processed, a response goes out. It works, but, a functional API just isn't enough. We've built the house, but we haven't put any locks on the doors yet. So now we've got to make it secure. Now, securing our API isn't about some single magic bullet. It's all about layering our defenses. We're going to start with two fundamental layers of control. First is authentication, which answers the question, who are you? And second is traffic control, which answers, okay, how often can you ask? To answer that who are you question, we've got some great patterns. We could use AWS Cognito to manage our own user database, handling all these sign up and sign in stuff for us. Or what if another service is handling identity? Well, they can give our users something called a JWT or a JSON Web Token. You should think of it like a temporary digital ID badge. Our API gateway can quickly validate its signature and claims to make sure it's legit. And of course, for simple machine-to-machine access, we can always just use basic API keys. So once we know who someone is, we need to make sure they're behaving themselves. Rate limiting is basically our bouncer. It prevents a single user, or maybe a malicious bot, from just overwhelming our system by sending thousands of requests a second. This is absolutely critical for protecting our backend services and just making sure the API stays available for everybody. All right, so our API is functional and it's secure, but we need to plan for success. What happens when our app goes viral and our traffic just explodes? A truly great API needs to be able to handle that success without slowing down to a crawl or breaking the bank. And that, right there, is the difference between an API that just works and one that works at scale. This brings us to the final layer of our architecture,
This is the stuff that really defines a professional, production-grade API. We're going to focus on two key things: making it incredibly fast through caching and making sure it's stable and future-proof with a smart versioning strategy.
So let's talk about speed. Without a cache, every single request for our most popular product has to travel all the way to our database, every single time. But when we enable caching at the API gateway, it's like giving a receptionist a short-term memory. After the very first request, it just keeps the answer handy and can respond instantly without even bothering the backend services at all. Seriously, let that sink in for a second. A potential 10 times improvement in response time. This is not some minor tweak. This is a total game changer. For your user, it means a snappy, responsive app. And for your infrastructure, it means a massive reduction in load. And that means cost on your backend compute and your database. This is honestly one of the most impactful optimizations you can make. Okay, so beyond just performance, a great API has to be a living thing that can evolve over time. And that's where a clear versioning strategy becomes absolutely essential. By using versions like V1 and V2 right in the URL, we can safely introduce new features or even breaking changes, all while giving our existing users a stable runway to migrate before we eventually retire an old version. So let's put it all together. We've walked the path of a single request, and we've made decisions at every single step. Now we can formalize all of that into a simple, actionable checklist that you can use for your own designs.
And here it is. This checklist consolidates our entire journey. As you can see, for each part of the architecture, there's a key question you need to answer. For entry point, it's REST or HTTP. For performance, it's how do I reduce latency? You should think of this as your strategic blueprint for every public API you design from now on.
As we wrap up, I just want to leave you with this one thought. Great architecture isn't about using the newest, flashiest, or most complex services. It's about choosing the simplest, most elegant solution that meets your needs today while still giving you a clear path to evolve for whatever comes tomorrow. So we've laid out all the components, the patterns, and the key decisions. The blueprint is right there on the table. Now the only question left is, what amazing application are you going to build with it? Thanks so much for joining me on this architect's journey.